direction cosines and direction ratios. Direction cosines, in short form, it is called as DCs, and direction ratios, they are called as DRs. Let's see what these DCs and DRs means. So consider the position vector OP of point P, X, Y, Z. So now this is the position vector OP of point P and its coordinates are X, Y, Z. Now, now the angles alpha, beta, and gamma made by this OP vector, which is also called as R, with X, Y, Z axis respectively, are called its direction angles. So here basically this OP vector makes angle alpha with x-axis and beta with y-axis and gamma with z-axis. So these alpha, beta, gamma are called direction angles. Okay, next, the cosine of these angles are called as the direction cosines, which is nothing but DCs of vector R, which means cos alpha, cos beta, and cos gamma are called the DCs of vector R. And these DCs are represented by L, M, and N respectively. So DCs are nothing but the cosine of angles alpha, beta, gamma. So next, let A be a point on x-axis and OA be a vector. Okay. Next, B be a point on y-axis and OB be a vector of that, and C be a point on z-axis and OC be a vector of point C. Now, this P point is in such a way that it makes right angle triangle with A point. Similarly, right angle triangle with B point and right angle triangle with C point. It's actually a straight line, but just understand, okay? Now, in triangle OAP, we can write cos alpha as OA vector by OP vector. OA vector is nothing but x vector, that is, this OA vector is x, OB is y, and OC is z vector. By OP is nothing but R vector, right? R. Similarly, in triangle OBP, we can write cos beta as y vector by R vector. And similarly, in triangle OCP, we can write cos gamma as z vector by R vector. So the coordinates of point P, which means x, y, z, can also be represented as LR, okay, MR, and NR. L is nothing but the cos alpha. Like from here, we can write x vector as cos alpha into R vector. Cos alpha is nothing but L. So L times of R. Similarly, Y can be written as M times of R and Z can be written as N times of R. Here basically it's not a vector, actually it's a side. We can like if we talk about the magnitude, it basically talks about the side. So X, Y, Z can be represented as LR, MR, and NR. The numbers LR, MR, NR proportional to the direction cosines, that are DZs, are called as direction ratios, DRs, of vector R, and these are denoted by A, B, C respectively. So DCs are direction cosines are denoted by L, M, N respectively, and DRs direction ratios are denoted by ABC respectively. One very important note here is the squares of summation of DCs, like direction cosines, that is L square plus M square plus N square, is always 1. But in general, the squares of summation of DRs is not equal to 1. That is A square plus B square plus C square is not equal to 1.